question asks, how many p electrons are there in an atom of rubidium? So I've outlined rubidium in red on the periodic table, and I'll quickly highlight the atoms that are involved in the electron configuration for rubidium. So all of these highlighted in yellow leading up to rubidium. And it wants to know the p electrons. So we can recall that the p block is on the right-hand side of the periodic table. And then we can outline in blue those p electrons, remembering that the helium is actually an s electron. And so this is 3 rows of 6 electrons. So our final answer is 18, or B. This question asks us to think about which sample contains the most molecules. Now we see that answers A through D all contain 1 mole of the compound or element. So when we're thinking about how many molecules are present, we need to think about the distinction between molecules and atoms. So if we're thinking about atoms, then carbon dioxide has 3 atoms, this UF6 has 7 atoms, etc. They all have different numbers of atoms, but they all are a single molecule. So our final answer is E. This question asks us to identify which of the following elements is classified as a metal. So let's go ahead and identify them on the periodic table first. So we have Ge, As, F, V, and Ar. So we notice that on the right-hand side of the periodic table, these are mostly nonmetals or metalloids. So we see fluorine is a nonmetal, argon is a noble gas nonmetal, and then Ge and As in yellow are both semimetals or metalloids. And then V here is a transition metal, so our final answer is D. We can practice determining which of these formulas for ionic compounds is incorrect by using the periodic table to look at the charges of the cations and anions that make up these ionic compounds. So using these left 2 columns, we know that the alkali metals will be +1 charge, and the alkaline earth metals will be +2. And then going over here, we have the +3 cations. And then if we think about the anions, we have these final 3 columns here. And the noble gases, of course, do not form ionic compounds, but with the halogens, we have -1, then moving over -2, and -3. So if we go through each of our response options, we can first write the charges for our cations and anions. So for the cations, we see that strontium is +2, cesium is +1, aluminum is over here with +3, and then that repeats. And then we have calcium, which is a +2. So now if we go through our anions, we have chlorine, which is -1. We have sulfur, which is -2. Chlorine again, which is -1. Phosphorus, which is -3. And selenium, which is -2. So let's go through and see how these match up. So since we have +2, -1, we would need 1 strontium and 2 chlorines, which is correct. This next option, we would need 2 cesiums and 1 sulfur in order for them to balance, so that is correct. We have aluminum, and then we'd need 3 chlorides to balance, which is correct. And then we see here that it should just be aluminum phosphide, but we do not have that. This is giving us an unbalanced option. So we know that this is incorrect, and our final answer will be D. And just to do our final check, our final option is balanced in charge, so it should just be calcium, selenamide, which I've never heard of, but those are our options. For this problem, we're asked which pairs of liquids are miscible. So when you see the word miscible, you should be thinking polarity. So let's first go through and identify each of these liquids as either polar or nonpolar. So we know that the organic compounds will be nonpolar. So that's the hexane and the benzene. And then going through, we can recall that methanol will be polar, and water, of course, is polar. So now for miscibility, you may have heard the expression like dissolves like. So in this instance, if you have two nonpolar compounds, they would be miscible. If you have two polar compounds, they would be miscible. And if you have a mixed pair, then they would be immiscible, meaning that they do not mix with each other. So if we look through, we see that pair 1 is both nonpolar and pair 2 is both polar, but 3 is a mixed pair, so our final answer is A. Let's practice naming of organic molecules. We want to know what type of molecule C3H8 is. So we see all of our options end in the suffix ane, which means they are alkanes. So we know that we can set up our 3 carbons in a row, and then let's just add in 8 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8. So this confirms we have an alkane. And since we have 1, 2, 3 carbons, as confirmed by our formula, we know that the prefix should be prop. So our final answer is B.